stuff out.
Yeah. Yeah. So I haven't done anything yet.
Yeah, I watched some of the videos, but I was a little lost. I'm trying to figure it out step by step.
Okay. So sorry. I was at a, women just like to talk.
No, you're good.
Lady started on, she's pregnant, and I started getting her started on birthing, and then, like she told me every birth story of all her children. And I just can't tell, I'm too nice. I have a hard time being like, hey, I have to go, you know.
Yeah,
So, anyway,
you're good. Don't
that's
worry.
okay. Um, so, do you want to like teach me what you've learned, or should I just go through this?
I can try to teach you what I've learned, but I'm a little lost. Like I was watching the videos and he teaches you everything on SPSS, and so then when I like logged on to the quiz already and was looking at it, but everything you use is on Excel, so I'm like trying to figure it out on Excel.
Oh, so you're using Excel.
Yeah, because
Gotcha.
like the program where he wanted us to download was on Excel, so I'm like, well, that changes everything. But we have to download something for Excel straight up, and then it has all the documents on it already, so it's not too bad after I figure that out.
Oh, so we have to do everything on Excel?
I think so, yeah.
Dang it! I have SPSS. I haven't
Yeah.
been.
I'm
I
a
haven't,
little annoyed that I paid for it because I haven't used it yet.
yeah.
Like everything he
Well,
has us do is on Excel.
I think I don't know how I got it, but it was already on my computer from last time.
Okay.
But I can't remember why.
Yeah, I had to pay like $50 for it or something like that.
I
And
might have illegally downloaded it, so
I should have done that.
I am a naughty person like that.
Yeah. That's okay. I'm not here to judge.
Good. Okay. So I don't even know where to start.
Okay. Do you have the quiz open?
Um, and, yes.
Okay. So I figure the first two questions I haven't like answered any of them yet, but I was starting to work on number 6, trying to with all that data, trying to figure all of it out. But
Okay.
so
Okay.
we can
Oh,
just start from the beginning and work our way through and try to figure it out together.
okay. Sounds good.
Okay.
Um, so there is a video that talks like there's a third video that says something about SPSS.
Yeah, I watched that one.
Is that like saying I just don't want to have to do things on Excel because I feel like that'll.
So maybe there's a way to open it, but so if you look at question number, like right before 6, like so right after 5, like all that data, it says use the following values which were pulled from the data file body temp, copy and paste them into the software you are assigned to use, and it's quantitative inference procedures. So I mean, I think there's a way to put it on SPSS. I just didn't find it, and so
I think I remember.
all I did. Okay, never mind. It's right under it. It's
Is it a link? Because there's a link to. Cause I'm,
I I only saw the link to the Excel one, but under it, maybe somewhere else.
yeah, there's a chart for Excel, and then down there there's a chart for um, SPSS.
SPSS. Yeah.
Do you have that link to that? Do you know what I'm talking about? Where it has all those different.
I couldn't. I don't see the one for SPSS. I just see the one for Excel. Like, there's no link that pops something open for it. So that's why the only one that I found was the Excel file.
Yeah. Can you send me? Is it like that? So that place you're at, is it a paid web page?
It's just in our textbook, so I can send you that if you want me to.
Okay. Oh. Okay.
So I couldn't find the SPSS one. So,
Um,
but the Excel one's not hard to use either if you have Excel.
yeah, I'm pretty sure I have Excel. Yep.
This class makes me feel like an idiot though. Like I have to like take my time on everything, and I'm like I have no idea what it's talking about.
Yeah, I don't like jumping in. I usually don't. I like to read it beforehand because if I just jump into it, I have no idea what's going on.
Yeah.
And just, I like the textbook, but I wish it was more like, because it has all the stories. I just wish it was like, this is the information you need, like in bold, like this is actually the important stuff, you know.
It gives us easier examples to like step-by-step stuff of how to do the like problems, because especially online classes that we have to figure everything out on our own. It's like it'd be nice to do a step-by-step so we can see where you're getting the numbers from. And
yeah, why? I'm curious. Since you're on campus, why did you do online math instead of on campus?
Because I found out one of the classes I was taking I didn't need anymore, like the week after school started, and so I dropped the class that week, and I needed to get more credits. So the only one class I could get in was the online one.
Oh, okay. They want to let you in the.
So I was like, okay, here we go. Otherwise, I would have taken it in. I wish I could have taken it in class, but
Yeah,
this is what I could do.
this is the one class that I would. Well, I would take. I'd rather be in class anyways, just 'cause
Yeah.
it's better. But
So much more busy work online too, like for a lot of classes.
is this what you're looking? This is what I was talking about. I don't know. Is that what you were talking about? Because there's so they have like all the Excel, but then lower, if you keep going, then there's SPSS.
Okay.
So is that what you were talking about?
Well, it just had it in the lesson that I had to open up.
Okay.
So in lesson 11, it just gives you the exact file that we used. So I didn't even go back to that. I guess it's there probably, but
Okay. Cool. Just wondering.
yeah.
Okay. So.
I just used what was straight from the lesson, and it just gives you the Excel link. It didn't give me the SPSS link from there.
Okay. Cool. Okay. So. Man.
All right. We start and figure it out as we go.
Okay. Let's do it.
Okay. So number 3. In previous lessons, we have assumed the population standard deviation O was known. In this lesson, we are making different assumptions with O. What has changed?
It's unknown. That's the whole point, is that sigma's unknown. I think that's what it's called. That little symbol is sigma.
Sigma, yeah.
So that's because it's unknown, right?
Almost never know yeah.
Yeah. The first line says, "In practice, we almost never know the population standard deviation."
Yeah. Okay.
Which makes sense, because I mean, if we're talking about the population, because the standard deviation is of the bigger number of the whole population, and if we don't actually know the I don't know. It just seems like we'd never really know that, anyways. Okay, so I'll read the next one. The null hypothesis is h0 theta equals 8, or mu.
I think that one's mu.
Yeah. Which one's theta?
That one's the one that looks like. That one's. Shoot, I don't know.
Oh, dang it.
I think that's the one that is that the one that looks like the little A, or no?
I was like, oh, that's alpha, but I've never heard them say alpha, because it's alpha in chemistry.
Yeah.
Oh, whatever. Okay. So the null hypothesis is that, and the alternative hypothesis is that, and the population standard deviation is not known. Becca collects a sample of n equals 9 and computes x bar equals 11 and s is 6. Let's use the information for a question factor. Okay, the value, so is that known? No.
It just literally says it's not known.
Yeah.
I think we're going to get that one right for sure.
He's got 10%, right? Or whatever. Okay. What is the value? Oh, sorry.
What is the value of t round to 1 decimal point?
Okay. So it has the formula.
Yeah, is that the formula of z equals x bar minus mu divided by whatever that one is?
Same thing, but s instead of the standard. So it's the population. Instead of the population standard deviation, it's the sample standard deviation.
Oh, okay. It's the
S, which is on here is 6. But that seems like it'd be really inaccurate since the n is so small, but
yeah.
Whatever. Okay. I'm going to write down that formula.
Yeah, me too, so I can see it. Right?
I have to write everything down. I can't just...
Of course I love having you. Dude. Thanks, man. Okay. So...
Okay, so in this case, let's
Did you get 0.2?
I haven't put it in yet.
Okay.
Hold on. I got 1.5.
It says to the nearest
Oh,
1.5.
no, 1 decimal point. Right? 1.5?
Yeah. What did I do wrong?
Wait, did you just get 2?
I got 0.2. That's it.
Oh.
Maybe I did it. I'm pretty sure I did it wrong.
Okay, so I did 11 minus 8 divided by 6 divided by this.
Oh, that's where I went wrong. I multiplied the bottom.
Oh, yeah, I've done that before.
That would change a lot.
Yeah. Yeah.
Okay. I was like, what?
Okay.
Okay. Yeah. I don't even have to go. 1.5. That's right.
Okay.
Okay. So this is the one I was starting to figure out on Excel. So are you doing it on SPSS?
Yeah, and I'm pulling it up.
Okay.
So I got it. Okay. So yeah.
Because I started figuring it out and I entered, like, it just pulls up something. So I think we have the same exact information with different programs.
We're using the body temps, right? As the
Quantitative inference procedures is the one I'm using. Because the body temp is just taken. He only took a few of the data from the body temp. So
it says use the following values which are pulled from and pasted. That's okay. That's weird.
So that's why I used the Excel sheet, because I didn't really know what he was talking about.
I'm pretty sure because it says use the following. Oh, pulled from the body temp.
Yeah.
Copy
It's
pasted.
it's not the full body temp, it's just part of it.
Oh, okay. Quantitative inference.
So I don't really know how to do that on SPSS.
Yeah. Well, I think you just copy paste.
Yeah.
Let me see. I think this is the point. I don't know if it's this week or the next week. I think I did this last time. But oh yeah, I just copy and pasted it and it did it.
Okay.
But I think it's this week or the next week that I dropped the class last time. Okay. So
I think it's funny because all of us have started a statistics class and dropped it.
really?
I started a business statistics class. And I did it for 2 weeks and dropped it.
And Kareen did too.
I don't know if Kareen did. Who was Marissa? I think it was Marissa.
Yeah, Marissa. She's like this. It was like her third time, right, or something.
Something like that.
Crazy. Okay. What does X represent?
That's what I was wondering too. I was hoping you knew.
Oh, dang it.
I was like banking on you knowing because I got to that point and I was like, I don't know anymore.
Okay. Because I know how to pull up the descriptive statistics, but okay, I don't. Okay,
Yeah.
so X is to. Let me think about it.
So X is the mean.
Oh, it's the mean. Yeah, it's.
It's the mean. I'm like looking at I'm looking at one of the examples. So
It is.
yeah.
So that's the mean of the sample, right?
Yes.
So it's the same. I mean, it's not the same, but it's the. Yep. Okay. Okay, so for the mean, so it would be 98.220.
And
So
then, yeah. And S is the standard error.
standard deviation.
It says STD error. I don't know how to get that number. Or wait, no. Where's that number at?
It says that's
Okay, that's the standard deviation. Yeah.
yeah. Standard deviation. Okay. And the t-score. So I don't know what that is.
Okay, so the video explained the t-score a little bit. Did the SPSS just give you all of the information? Because mine didn't give me the mean, the standard deviation, or.
Really? Yeah, it did. It gave me. SPSS gives you a lot.
I just need to figure out how to use that program. What'd you get for what's the F score?
For the what?
What's
for
number 7? What'd you get?
0.922.
Okay. And then the t-score.
So I guess for the t-score we have to do the formula again, like before. So yeah,
Okay.
98.22 minus 90.
He was showing us a way to do it. I just can't remember.
Yeah, well, it's just the same. It's like the same as number 5 on the quiz.
Okay. That's true.
And then I guess for n, we just count all those the number of that, right? The number of these. Oh, too many folders up. So 20. Because there's 20 that they pulled from. That's my guess.
Yeah.
I got a negative number.
Is that possible?
Yeah, it is.
Okay.
Oh, yes. What are t-shirts and splash? Okay. I got negative 1.8.
1.8, yeah. Need 1.843, blah, blah, blah. Okay. 43. Okay. What is the p-value?
Do we use a tablet?
I think we use that. Yeah.
Is that in the homework at all?
No, it's in lesson 5 though.
Yeah.
I find where that's at. I wish he put it in every one or had something we could download to use it.
No, I hate trying to find it every time. So what?
So what number do we put in? Do we put in 1.843?
Negative one. Yeah. Can you send me the link?
Yeah.
To Thank you. What is that? Okay. Okay. So what are we trying to? What's the p-value? What's the p? Well, how do we know? What do we shade?
I don't know. I think it was the outsides. Didn't we do the outsides last time?
What?
I don't remember.
I don't know.
Shading the outsides, I got 0.0653. We did PI last lesson, right?
Because it doesn't say anything about p-values in this one, right? So do you remember what?
Okay, so in this one, on one of the examples, they're shading the outside.
Number.
But
Yeah,
that's just
p-value.
brief.
Okay. Okay. Yeah, that works for me. Compare.
Okay.
Yeah, let's do that.
Okay.
Where'd it go? Okay.
Did you get 0.065?
Yes.
Okay. Sweet. Okay. What is the correct decision based on the evidence? This evidence.
Oh crap. Okay, so you have to do that thing where the p-value is small. If the something is low, reject the, I don't know.
So it's less than.
Well, do you remember what less than that is?
It was like 9 or something like that.
Okay, I want to see if I can find it, because I'm not going to trust myself on anything.
All I'm saying is I'm glad we have groups, because I don't think I could figure this out by myself half the time.
Well, and it's good because I feel like it teaches us, it helps me, there it is, okay. It helps me, like, solidify it in my mind.
Yeah.
Okay, so, wait, what's the question again? Reject a null or, if the p is low, reject the null. That's what it was. That's what I was trying to say. Okay, so the p is the level of significance, and our p is 0.05. So is that low? What's considered low? That's the problem.
Well, it is less than. So I think we would reject the null hypothesis.
Okay.
Because the null hypothesis is mu equals 98.6, and the alternative is it's less than 98.6. So, yeah, we would reject the null hypothesis. Yes. Okay.
Because what? Sorry. What?
I reject the null hypothesis.
I know, but
Because the null hypothesis is mu equals 98.6, and the alternative hypothesis is mu is less than 98.6. So anything less than 98.6 is rejecting the null hypothesis. Does that make sense?
oh, because we got x bar as 98.2.
No, like when you read the whole question, when it says use the following values, it says that using the null hypothesis of mu equals 98 it tells us what the null hypothesis is, and it tells us what the alternative is.
Yeah,
so,
yeah, I see that. So
the p-value is less than 98.6, so we know that we rejected the null hypothesis.
I think
I feel like that p-value is wrong.
No, it's not, because we're not comparing it to that because that's the mean. So our mean is 92.8. I mean 98.2, and that is less than 98.6.
Okay. Yeah, you're right.
So the p-value is the level of significance, which they said at the beginning is 0.05.
Okay.
So our p-value is actually bigger than that one. So I remember they said somewhere where what is considered low, but oh yeah, see the most common value for alpha, I don't know how to alpha or the p-value is 0.05. This is so when the
Okay.
So I think that we'd actually fail to reject.
Okay.
Does that make sense? The value can be very small. Things strike a good balance between them. Sorry, 1 second.
You're good.
I just want to make sure I'm having the right train of thought. Okay, so Yeah. It says we will use the same decision if the p-value is less than alpha. That's just what I'm going to call it because I don't know what else to call it. That little fishy thing.
Yeah, I know what you're talking about.
Okay. If the p-value is less than alpha, we reject the null hypothesis. Conversely, if the p-value is greater than alpha, we fail to reject.
So we're comparing it to the level of significance then.
Yeah.
Got it. Okay. And
yeah, because alpha, whatever, is the level of significance for the whole population, but the p-value is for the sample that we have.
Okay.
Does that make sense?
Yeah. Okay, I agree.
Okay. Awesome. Cool. So I'm guessing the next one is probably going to be the same thing.
Yeah. Use the following values, which are pulled from the data file Baby Boom. These values are the wait time in minutes between births at hospital. Copy and paste them in the software you are assigned to use. Quantum procedures, SPC, blah, blah, blah. The hospital claims that the average time between births is 40 minutes and plans it resource allocations based on this claim. You want to test their claim. You select U equals 40.
Okay.
Okay.
Your first alternative hypothesis is just not important, and you use a level of significance of 0.01. What is the p-value?
Okay.
It's like making us go back to different.
Yeah, different lessons.
Oh, okay. What lesson is that? That was like the last one, right?
I think that's 10, yeah. See, I feel like Corrine knew how to do values the best, because I was banking on her half the time.
What?
I said I feel like Corrine knew a lot more about the p-values. She somehow knew what she was doing.
Yeah. I don't know how to find that. Wait, how did we just do the last one?
We had the t-score, and then type that into, so.
Okay, so that's what we need to do this one, right?
Yeah.
What is telling us the level of significance for?
So we can,
compare.
So if we know to reject it or not.
Okay. Okay, I was like, I don't know how to plug that into a thing, but we don't have to plug it into anything. Okay. So we do this, we find the T, whatever, the T thing.
Yeah, t-score.
So, okay.
So what's your say for the mean and stuff?
So for the mean, I got 40.04 8. And then for S, I got 36.356.
Okay. And what'd you get for N? Does it tell you N? Or never mind. I can skip that.
Where did it go?
21.
21. Alright, so
40.
Oh, I got 0.006.
Yeah, 0.005.
Okay, let me put that.
So did you get 0.9952?
I haven't put it in yet.
Okay.
Yes, I did. 0.9952. Okay, so what is okay. So I would assume failed to reject because that's huge, right? Because that's high, because that's more than the level of significance. It was like the last one.
I think low isn't low we failed to reject.
No, when it's low, you reject it.
Okay. So yeah, failed to reject.
Yeah.
Okay.
When the P is low, reject the null.
Okay.
That's a big P. Because P value is in between 1 and 0. Okay. Connecting circles. Okay. You decide to try another alternative hypothesis. This time you use mu is less than 40, and you keep the same level of significance. Did the P value increase or decrease? Would it matter?
Apparently. I don't know why though.
I don't know why either. There should be a third one saying doesn't matter.
According to what we understand, it does not matter.
Yeah. Are we doing everything wrong? Okay.
I sure hope not. I say it would decrease.
It's so late. Wait, I remember vaguely talking about something. The differences. Okay, there we go. Oh, okay, so for this one okay, because, here, let's see if I can copy that. That's, yeah, does that work? So, okay, so last time, it was that first one, so we shaded the ends of the, okay, but this time we only shade the left. Because it's less than.
Okay, so last one we were supposed to shade. Were we supposed to shade both of them? Or okay.
Yeah, because remember we went to the probability app and we shaded in the ends?
Okay, yeah, so this one's less than, so we would shade just the left of it.
Yes.
Okay. And so then it would decrease then.
Yes. But we might have done the number 9 wrong then because we shaded both of them, and I think you only have to shade the left.
I think you're right. Dang it.
I know. Okay, but all we have to do is put that back in.
Yeah, I guess it doesn't change too much, huh? It just changes. Yeah. It just changed the last one.
Yeah, and making our answer more.
Yeah.
Okay, no big deal, right?
Right.
So we just shade the bottom one, which changes to 0.03, which is now less than, so we reject. Is that what we're thinking?
What are we talking about?
Sorry.
Did you just continue to 14?
No. So for 9, I changed my answer to 0.033. And then for 10, I changed to reject.
Okay.
Because that's now smaller than the level of significance.
Okay. Yeah.
Okay. Okay. So then.
So back to 14.
So I'm gonna. Oh wait. What was the t-value we got?
0.006.
Okay, so then we just shade just the bottom, and it would be 0.5, which is still higher than 0.01.
So we'd still fail to reject.
Yeah. Okay.
Okay. Compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one is wider? What's the confidence level?
You're really going to make us do that? Okay. Maybe, okay, so I'll just do the margin of error then. Right? No. It's X. So So the only thing that changes between those two is the p-value, right? So
I think the larger the number would be the larger the confidence level of it. So I think 11. Because I think it was talking about that somewhere.
but they're with the same numbers, aren't they? Oh, you're talking about the p-value?
Yeah.
But with the confidence intervals, you don't even need the p-value to find the confidence intervals.
Okay. Then I'm wrong.
That's why I'm thinking they're the same. I mean, I I could, if you want, I could make the formulas. I could find out the actual confidence intervals of both of them, but I'm pretty sure they're the same.
Okay, I think so. Yeah, 'cause it's the same number we're using.
Yeah, exactly.
Okay.
That's my.
Okay, I'm down to put that because I don't really feel like working it out either.
Yeah. Okay. Then should we?
So, here we go.
Yay! We only got 9 wrong, which we just changed.
I wonder if we were right.
Yeah.
Good job.
Yeah. Okay. Hey, we got 94. That's awesome.
No, I was saying good job on the 94. I wasn't like criticizing the changing it.
Oh. No, sorry. Maybe. I mean, we could just be off by a couple decimals or something.
Yeah.
Right? Okay.
It's all good. I'm not too worried about it.
Yeah, me neither. Okay. Well,
All right. Awesome. Well, you have a good night, Emily.
You too. See you next week.
All right. Bye.
Bye.